So before you start the review, or if you've started already, that's fine. But before you finish the review, there may be some formulas that we used in this chapter that you'll need. So I just want to go over those. And they're the real life application things. We have the growth or decay formulas. The growth or decay. So there's two, one's for growth, one's for decay. I'm going to write them together. So we're going to start out with y equals a parenthesis 1 plus or minus r to the t. So the plus would be for growth, the decay would be for, the minus would be for decay. So it's the same formula, just either a plus or minus depending on what. So if we have a formula that says something about increasing or growth, then we'll use that plus sign. If it says something about the amount going down, decreasing by some sort of percent, then you're going to use the decay. Remember, the R is the percent over 100. So it has to be a decimal. If it's like 15% and you put 15 in there, you're going to get it way wrong. You have to be 15 out of 100, which is 0.15. You remember what T is? What kind of time, though? It's years. Usually it's years. These are all going to be years. And A is the Jackson. It's the amount. Is it the starting amount or the ending amount? Starting the amount. Yes, the starting amount, the initial amount. Okay, and then Y would be the new amount. So that's one formula you might need. And then we take that formula and we're going to change it just slightly. We're going to talk about interest compounded interest. I was going to say compounded by a certain number. But it's compound interest is what it's called. That's the one that's compounded monthly or compounded daily or compounded biweekly. I don't know. So that one looks a lot like the growth and decay. Only use some different letters. They do A, capital A. They do capital P. 1, and it's always plus because interest adds money. And then we have our rate over N to the T times N. Now, the way that we labeled these is very similar to the way that we're going to label this. This capital A is still that new amount. The P is called the principal, but it's the initial amount. The R is the percent over 100, the rate, percent over 100. The T is the time in years. And then the only thing new is the n. And the n is how many times compounded per year. Number of times per year. And that goes in two different places. There's the PERT formula, which is also interest compounded, but it's compounded continuously. I better put a label on this. Interest compounded continuously. So all the time. So the A is the new amount, just like it is in the purple one. The P is the principal, just like it is in the purple one. The R is the percent over 100, just like it is in the purple one. The T is the time in years, just like it is in the purple one. The only difference is this R is in the exponent, and E is that button on your calculator, that 2.7183 number. But all of the labels are the same. E is not a variable. E is the number. I think those are all the formulas that we did that you would need that they might not give you. It might actually be given to you in some questions, but just to go over that. And then the thing that we did last time was logarithms. Let's go over something real fast about logarithms. I still have some space over here. So log is the inverse of exponential. If I write log base b of b to the x, the log base b and the b are inverses. And when they are inverses, what happens? And if they're inverses and next to each other, what happens, Amar? They cancel out. So this answer would be x, right? If I have b to the log base b of x, this exponential and this logarithmic are inverses, and they would cancel, and we would get x. That's what inverses do. They undo each other. If I have ln, what is the inverse of ln? Cannot hear. E, yeah. E, and then I'd put to the x. If I have ln of e to the x, those cancel and we get x. Or if I have e to the ln of x, the e to the ln cancel and we get x. So I've got 4 situations here where we've got inverses. So as you're going through this, there are some questions that you should be able to do without the use of a calculator. Okay, let's look at number 1 together. It says evaluate the logarithm. So we're going to simplify anything we can simplify. When we look at logarithms, can I cancel the 7 and the 343? No, because they're not the same. Log base 7 and a base of 343 are not the same. So what you do is you change this so that 343 is now 7 to an exponent. You could only do this by hand if it actually is 7 to something. If 343 wasn't, then it would be a calculator question. So 7 to the what is 343? I know it's not squared. Any guesses? It is 3. 4 would be a really big number, so it is to the third. Okay, so if I have 7 to the third, which is 343, and I replace 343, then I can go boom, boom, those cancel. My answer is 3. That's what a logarithm is doing. It's saying 7 to what exponent is 343. It's finding the exponent. And why does log seem difficult? Because it's brand new. That's the only reason. The more that you practice it, it's not going to seem that difficult. The next one says evaluate log 1.6 using a calculator, round to 3 decimal places. So how would I evaluate that on the calculator? Tessa, what am I going to do on my calculator? Did you say multiply? Is that what you said? Okay, so it's not multiply. It's just you're going to hit the log button. It'll automatically bring up log, and I think it brings up a parenthesis. And you just type 1.6. So it's not multiply. You just type it in there and hit enter. That's it. It gives you a nice, lovely, big, long decimal, but we are rounding to 3 decimal places, so 0.204. Oh yeah, number 6. Let's look at number 6 together. I was trying to remember which ones I wanted to do. So number 6 says, in a lab, 370 cells are present at the beginning of an experiment. During the first 9 hours, the number of cells increased by 10% each hour. Write an exponential model giving the number of cells Y present T hours after starting the experiment. And then second part of it, estimate the number when the, estimate the time when the number of cells is 600. So we're going to do an exponential model. This is not being compounded more than once. This is just straight up an exponential, either growth or decay. So when I look at that, how can I tell if it's growth or decay? Aya, how can I look at number 6 and tell if it's growth or decay? Can you say a little bit louder, hon? I'll give you a hint. It's in the second sentence. The word increase. Good job. This word right here is telling me it's going to be growth. Okay? So we just need to use our vocabulary. It's going to be growth. So that means I'm going to be using, I'm just going to copy it down from above. It was y equals a times 1 plus r to the t. So in this question, y is the new amount. But this says that we're going to be writing a model where y and t are variables. That's what it's saying right here, that y and t are going to be variables. So I need the initial amount and I need the rate. Brooke, do you know the initial amount for question 6? 370, good. And then we're going to add the rate. So Ariana, the rate. It would be 10 over 100, so 0.1. Perfect. And then we do that to the t. Now, the reason why I'm going over this one, because every single year people feel like they have to plug in 9 somewhere. And I want you to know during the first 9 hours, this is what was seen. What's the word? I don't know. I can't think of my vocab word. During the first 9 hours, they observed. That's the word I'm thinking of. They observed that it increased by 10% each hour. Okay. So they're just telling you some information that you actually don't care about. This during the first 9 hours, that's how they determine that it's 10% each hour, but we don't need that for the problem at all. Okay, so that's why I really wanted to go over this one, is we're not using 9 at all. So this is our model. Actually, let me simplify it. So just simplifying it, it would be y equals 370 times 1.1 to the t. So that would be our model. That's the first part of that answer. And then the second part, estimate the time when the number of cells is 600. So we're going to have to plug 600 into the new amount. Equals 370 times 1.1 to the t. And it says estimate. This is when we went and plugged it in our calculator. So let's do that. If you have your calculator, make sure you play along so that you know what to do on your own when I stop talking. So I'm going to go to y equals, and I'm going to put my model 370 parenthesis 1.1 to the, and there isn't a t, so I will use x. Now you cannot plug in 600 here because this is the model. Now what we do is we look at our table. I mean, you can look at the graph, but I think it's easier to look at the table. And my table is way at 21. So I'm going to go to table set and make my table start at 0 and then go back to my table. So I'm going to look to see at what year it turns into 600. Question? Second graph. Thank you for not waiting 10 minutes to ask. Okay, so now we're going to look in our y column and we're going to find when does it turn to be 600? Just after 5 years, yeah, just right after 5 years. So that would be about our answer, about 5 years. Now, I couldn't get that without looking at, actually I can, but I haven't taught you how to get it without looking at the calculator. Okay, so that's all we're going to have to do for these questions for the test. Does anybody have any questions about this one? Yeah, Mar.
So we don't have to like give like an exact amount when we click that, it's just like an estimate.
Yeah, yes, because it says estimate. Do you know how to the exact? Okay. I bet we could figure it out, but that's for a different day. That'll be fourth quarter. Okay. All right, so those are all similar in style. Let's go down here. If you have to rewrite an equation in logarithmic form, if you have to rewrite an equation in logarithmic form, I'm on like 14, 15, 16, 17. And I'll just do 14 with you. If you have to rewrite an equation in logarithmic form, you're going to log both sides. That's what it's asking you to do. Log both sides. So I look at number 14 and I ask, what is the base? I asked myself, and somebody answered it correctly. I asked myself, what is the base? And for number 14, the base is 4. So I'm going to log both sides with a base of 4. So I put log base 4 on both sides. Log base 4 cancels out the base of 4. And we get 0 equals log base 4 of 1. Or you can rewrite it as log base 4 of 1 equals 0. Either's fine. That's how we change it to logarithmic form. We just log both sides. Go to number 32. It says rewrite the equation in exponential form. For number 32, if you're asked to do it in exponential form, then you're going to exponentiate both sides. So I'm still going to ask myself, what is the base? We're going to exponentiate both sides. What is the base for number 32? Somebody yell it out. Yee, come on, zoom out. What's the base? 3. So when I exponentiate, I put a base of 3 on both sides, meaning the sides become the exponent. Oops. A base of 3 and a log base 3 undo each other. We get 1 equals 3 to the 0, or we can write 3 to the 0 equals 1. Either of those is fine. And now we canceled out the logarithmic, so we put it in exponential form. I'm not solving these. I'm just rewriting their forms. You're using the same method that you would use to solve them. There just isn't a variable to solve for. Let's see if there's anything else that we really need to go over. Here, we'll do one of these solving equations. I don't want to do a bunch of them because I want you guys to have the practice, but let's do, I'm at number 45. So we're solving this and we need to get x by itself. We need to get rid of the thing that is furthest away from x right now on the left side. So if I say 2 times x minus 3 and then 3 to that power, the base of 3 is the furthest thing away. So I say, how do we get rid of a base of 3? We log, okay? If it's exponential and the x is in the exponent, we log. So we're going to log both sides. And then I ask myself, what is the base? Three. So I'm going to log base 3 both sides. So log base 3 cancels out the base of 3, and I get 2x minus 3 on the left side. Okay, the next thing I'm thinking when I see log base 3 of 27, and I know 3 and 27 are kind of related by exponents, can I simplify this log? Can I evaluate log base 3 of 27? Do you know what I mean by evaluate? No. Okay, so log base 3, I'm going to take 27 and make it a base of 3. What is 27? 3 to the third. Okay, so I didn't change anything. I just said, well, 27 is 3 to the third. But now that I said that, what can I do with log base 3 and the big 3? Cancel them out. Okay, so now I have 2x minus 3 equals 3. We have no more logarithms. This is an easy equation to solve. Add 3, divide by 2, check our answer just to make sure. Oops. Okay, so I got 3 to the third equals 27. That's a big old check. Before you guys get started, I'm just really curious. Can you give me a dial of a thumb how confident we feel with the logarithm stuff? What's your thumb? Sorry, I just want to see everybody's thumbs. Okay, so there's a lot of middle of the way. If that's the part you feel the least comfortable with, because I didn't ask you about anything else. This the logarithm was just the newest stuff, and I know it's always like confusing because it's brand new, but I promise you it's easy. Don't stress about it. I promise you it's easy as long as you practice. But anyway, if that's the stuff that you're least comfortable with, then go through this and be like, oh, here's some logarithm stuff. I'm going to start with that. Okay. Like here's some solving equations like that your teacher just, no, not that one. Here's some solving equations your teacher just went over, and I lost it somewhere in here. Here it is. So maybe I'll start with that and see if I can do one on my own. Okay, and that way you can ask me questions. We've got, a little bit less than an hour left today. Use that time wisely. All right, I'll be walking around, or if you guys don't have any questions, I'm just going to work on grades. All right, for graphing with me, I'm going to go over graphing. I'm looking at number 35, and it doesn't say to do this, but there's another question that asks about if it's growth or decay. So I'll go over that on this one as well. But this one does not ask about writing if it's growth or decay. But when we do growth, it's going to get bigger from left to right. When we do decay, from left to right, it's going to get smaller. So that's one hint when you graph it, if it's growth or decay. But you can look at the equation and usually tell by the equation. You're going to look at the base. And if the base is greater than 1, then it's going to grow. If the base is less than 1, oops, that's not a 1. If the base is less than 1 but greater than 0, some fraction between 0 and 1, then it's going to be a decay. So I'm going to look at this one, and my base is 3. So I know that this is going to be a growth. Okay? You didn't have to answer that for number 35, but there's another question where it does ask you to answer it. So just thought I would go over that here. We have to write the transformations. So when we look for f of x equals 3 to the x, and when we look at g of x equals 3 to the x plus 2, the transformation is in the exponent. So any transformation in the exponent will be horizontal, which means that we do the opposite operation. I ran out of space. Let me fix that word. If it's horizontal, we do the opposite operation. So with exponentials, we use the same key points, -1, 0, and 1, and we have an asymptote. There's nothing here that will help you remember that there is an asymptote. You have to remember there's an asymptote. It's always y equals 0 unless we transform that asymptote. And to find the key points, I'm just going to plug in -1, 0, and 1 into 3 to the x. Plugging in 0, 3 to the 0 is 1. 3 to the first is 3. 3 to the -1 is the reciprocal, 1/3. So those are my key points, -1, 1/3. I can graph those as well. And my asymptote at y equals 0. So here's my parent function. So now my transformation has a +2 in the exponent. So that's horizontal. I'm going to translate 2 units. But since it's opposite operation, when I say +2 there, it's going to go left. And because it's horizontal, it goes on the x side of the table. Horizontal goes on the x side. It's opposite of +2. So I'll have -3, -2, -1. That does not change my asymptote because my asymptote is on the y side. This is on the x side. I'm going to take this parent function and I'm going to go left 2 with every single point. My asymptote did not change, so it's in the same place. The domain is how far to the right and how far to the left. These arrows mean it's going to go forever, all real numbers. But my range is down to up, and it does not go all the way down. There's something stopping it. That asymptote says, nope, you may not pass here. So the range is going to be that y is greater than 0. It is not greater than equal to. It is just greater than 0. Okay? On the test, I'm not going to have you graph, but you might have to fill out the table. Okay, I'm not going to have you actually plot the points, but you might have to fill out the table. So you need to know how to do the table. That's what you really want to practice. And then plot them, make sure you know how to graph it with an asymptote, but let's make sure that we really know how to fill out the table. Okay? So there's plenty of graphing ones. Oh, I know what I want to say. What would move the asymptote? This question did not move my asymptote. What kind of transformation would move an asymptote? Does anyone have an idea how I can move that asymptote, that horizontal line?
A vertical transformation?
What kind of vertical transformation?
Negative? I don't know.
What did you say?
Something that ends up being negative, so then it would go down further.
Go down. Go down. We could take this line and we could move it down, or we could move it up. What's going to move it up or down? Vertical what? Jacob? A translate, yeah. So if we had like a plus or minus at the end on the outside of the, like if we had a times b to the x plus some number, it's a vertical translation, vertical translation. Up or down, that's what's going to move the horizontal, the asymptote. That's the only thing that would move it. Other than that, it's going to be at y equals 0. Okay, I was answering a few questions for people. I would just want to see if there's anything else that I missed that people were asking me about. Quickly going through this. I know that there were a couple questions. I don't remember what numbers. Here they are. 30 and 31. It says then graph. I forgot to add in graphs for you. So you're gonna have to do this. Oh, that was so hard. Right? Sorry about that. I apologize. I tried to look over it, but I didn't. I missed this. So number 30 and 31, you're just gonna have to draw your own graphs in. Sorry about that. But you can zoom in really far. Okay, was there anything else people were asking me about that I missed? Going over it earlier? I don't think so. Okay, if you do have other questions, please feel free to ask.